On to problem 5, we have predict the enthalpy value in kilojoules per mole for the reaction. And this is the second step of propagation, so we should be familiar with it. And we're given bond dissociation values in the proper unit, so we don't have to do any conversions. And an option of A through F. Okay, so first we're going to try to figure out for our equation which bonds are broken and which bonds are made. So our equation, which will give us our answer today, is the sum of the bond dissociation energies of bonds broken minus the sum of bond dissociation energies of the bonds made. And that gives us delta H. So it should be enthalpy equals. Okay. It's important because the negative values of bonds made are completely different because it's dissociation, not association. That's why we flip it to negative. So if we were to make if we make a bond, we flip B to E basically because it's association, not dissociation. All right, but now looking at our equation, we have to know how to get from this step to our products. So reactants to our products. To do that, we can first figure out through propagation what went on. But if we just were given this, we know that we're ending up with a radical chloride. So that tells us a half arrow. Remember, half arrows are for radicals or individual electrons. And that will end up with that. And then we made a bond between a chloride and a carbon. So that would look like the other electron meeting with this electron in the radical. So we made this bond highlighted in yellow, and we broke this bond, which I highlighted blue. So that bond over here is a C double bond, chloride double bonded chloride, sorry. So that's this energy. And highlighted in pink, we made this bond over here, which is 80. So we can plug and chug that right away. We end up with 58 minus, because it's the opposite, negative 80. And that would give us negative 22, which is D, our answer.